The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dana Pont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Friday, June 9th, and it's a little bit of an unusual time for us, Dane. This is day 3 of this newest outburst of Kilauea's activity. We covered that first few hours on the morning of the 7th, and then I did another update on that evening, and so we have day 2 and 3 to catch up on today here. I know we've been busy all week, so unusual time for us, but how you doing, man?
Yeah, I mean, it's been an interesting week. Very exciting up at the summit of Kilauea, being able to, see the beginning of the eruption and then catch it on day 2 and 3 as well. So we've been up there, checking the data as we normally do, but being up there every day so far of it, something I normally don't do at least.
Right. Right on. Well, yeah, we will review the imagery. We have a lot of short little videos and selected a few images. There's so much imagery online that we're not going to cover all of it, but I just thought I'd pick out a few things that stood out to me. And we'll go through it. So mostly imagery. We'll go through the signals as well, although the signals are not as interesting as they often are before an eruption, because now it's pretty obvious what's happening. And yeah, the biggest hazard is still the gas. Lots of gas coming out, so we'll cover that coming up here pretty quick. Anything you want to get into before we jump into it?
No, but if anybody has any questions, go ahead and throw them in the chat, and we'll try and get to them at the Q&A at the end.
Yeah, sounds good. Thanks, Dane. All right, so let's transition here to our Hawaiian Volcano summary. Hold on, I just gotta fix something on the screen here real quick. All right, transition this over there. So before I get into the summary here, I just want to share this. Our opening picture here is a current webcam view from the KW camera of the lava lake and that new little vent that's opened up here. So, all right. So today's Hawaiian Volcano summary. Kilauea is still erupting. It's filling much of that inner crater floor, although in the last day it's really retreated from covering the entire floor to now covering this horseshoe-shaped lava lake against the western wall. As well, that western basin that hosted the lava lake previously and the end of 2022 is also reactivated right in here and has been spilling over into that horseshoe-shaped lake out there. So that's the first visual thing. Now we can look in at the live stream here from the USGS and get a little bit of a wider view. And we'll just keep going and show you guys the thermal imagery that's been released. So here's an image, the thermal image that was released for the first day of eruption. And on this image, all the colored stuff is actually lava lake, with the reddish spots being the active open vents where the lava has been bursting into the air through small fountains there. So lots of spots here you can see, but you can see the color covering the entire floor of the crater there. We advance to the image that was released for the following day, for yesterday. You can already see how much the lava has retreated away from that eastern side. We have this big dark area right here. We do still have lava reemerging in that eastern basin, but it does appear through the time-lapse videos that we'll show in our full update that it's begun stagnating and overturning as well. So it seems activity is shifting to these western vents over here. There's one by this old west vent complex, the western basin itself, and some other spots by that old, what I've been calling the west vent 1.0 from the first eruption, December 2020. That is in this area more or less over here. So zooming out, what this looks like within the greater caldera is just that inner crater right there. There seems like there might have been some close to spilling over, or possibly some very small scale spilling over in this area right over here by the northeast of it. But for the most part, it seems like the lava kind of surged out, reached that higher height, and it seems like it must have lost a good amount of gas because the level then dropped back again. And maybe it actually was close to overflowing when it was the frothy stuff, but ever since then it seems to be back down. So it's close to the edge. It could be close to overspilling that cliff right in here, but it's going to have to refill more after its initial burst there. So that is the summary for Kilauea, and Mauna Loa is still quiet with no effect to report. And that's our Hawaiian Volcano summary for today. So let me get my pointer situated here, which seem to not have set up. Okay. Uh-oh. Apologies, you guys. Let me just get this. Let's see if I can get it to appear. Oh no.
No,
All right. I guess we'll have to go without the brush here because it's not cooperating today. So, moving on. Let's cover our hazards here first. And let's find the right tag. Volcanic hazard is the first thing to talk about, since with a new eruption, there's often some triggering that occurs with our local residents here. So here is the VOG forecast. The gases coming out of the volcano are really the biggest impact right now. Since the measurement was at a high of 65,000 tons per day on the very first day, the measurement yesterday was 21,000 tons per day. And that's the actual map here you see showing Kilauea as a source with 21,000 tons per day, where the weather is taking that VOG. So you can see a lot of it's going offshore. We'll cover that here in a minute. But zooming into a little bit closer, here is the island itself, and a lot of South Hawaii getting heavy VOG impact, as well as much of Kona as well, right? It seems like the eastern side across the saddle seems to be fairly clear, and that may be because we've had some decent winds coming through. But the wrapping around Mauna Loa and getting caught on the Kona side seems to be in effect now, and we'll have to reports from you guys who are watching. If any of you guys are watching on a Kona side and have something to report, please feel free to drop it in the chat, and we will share that with everyone as well. In the meantime, what we can go on is the Purple Air Citizen Science Network here, and people who have these instruments installed at their house with internet connection will then report this automatically. So you can see here in the Kona side these yellower values showing that VOG effect. And actually on this map earlier today, green down here in South Hawaii, sometimes that VOG blows overhead, not right at ground level, and sometimes it comes across ground level, so it can certainly vary in these locations as well. But this would be the main area of impact right there. Looking in the national park, coming to the charts here, everything's been in the green all day that I can tell in a national park. So very close to the caldera there. It does appear that the gas is rising enough and getting blown from the east to stay out of the areas where it's being recorded here, right, where all the people would actually be. So if you're there visiting, it's been pretty good. Of course, you have to take all your precautions as the park directs there, especially if you have any preconditions that might make you more vulnerable to that gas, like asthma, for example. So there's the air quality in the park. And I thought I'd just throw in windy.com today, because you actually can see here this big purple blob in the middle is the SO2 coming from Kilauea's eruption. And you can see it's still caught in this little whirl here in the Central Pacific. But at some point you might see this drifting elsewhere as well. So just to zoom it in a little bit here, you can see how large this cloud drifts offshore. And looking at the map, you can see that there might be some effect on Maui, in fact, too, and possibly coming to Oahu. This forecast is playing. Let's see if I can jump it ahead here. Saturday, Friday morning, a little bit later Friday, Saturday, and it seems like it's going to clear across the islands, but possibly even to Kauai a little bit there, you saw, yeah? Over the weekend, maybe Saturday, somewhere in there. If I zoom it out some more, maybe you can see the progression a little better. How that patch is predicted to evolve here. So there's Friday morning, moving forward on Friday, Saturday, Sunday, and then it will start drifting across the Pacific after that. So that's just interesting to note when we have these big initial outbursts of gas, how they can really put out a global signature that can be detected from the satellites here. So pretty cool to see that. But that will conclude our gas section here, and we'll move on to our Kilauea observations and visuals. So this is the F1 camera, and what I have here is a time lapse from when eruption began. With that big burst, the whole crater floor flooded. You see all the vents as the bright spots in the foreground. The ones in the background start to wane. They're not quite as bright. Even the ones by the central island seem to be gone by this point in time right in here. You do see that eastern basin have that lava lake persistent, but everything else is turning this darker color here, as this whole piece of land seems to be either uplifted or a combination of being uplifted and the lava around there actually receding down as well. We mentioned that the lava level dropped a little bit, likely because of gas escaping from it, and a good amount of it to lose a decent volume there. And here, the most recent frame that I took from earlier this afternoon, you can see there's one vent on its western side leaking out from the edge of the central uplifted area, and that's feeding this horseshoe-shaped lava lake. You do have the western basin itself refilled. It does appear that it has refilled. There's a lava tube right through here that connects this western basin to this, we call a southeast pit of that western basin. So it seems like it's refilled through there and reoccupied that. And we know that there's recirculation back underneath the crust from there. The lava often would kind of come up and go through and then drain back underneath there. And that's why the whole crust would over time lift up, raise and deform and that kind of thing. It also likely comes through this west vent complex over here. And it's not quite clear if this is what's connecting and feeding these vents over here, but there could certainly be other outlets. If we play it again and go from the beginning and look at where the actual fountains appear, there are fountains right in here and over here as well, so it could easily be cracking up from that side directly, but it could also be flowing through that network of passageways just within the crust up there. So interesting to see that there's that one, this one over here to the left, a little further north, seems to have waned by this point in time. You see the lapping of that northern arm of that horseshoe lake seems to come and go right up in here. And there's still one little pit just northwest of that central island that still remains as a high spot there in the middle there. So very interesting. This is all fairly zoomed in, of course, kind of tight. We got the edges cut off. The F1 camera is not a wide angle. So to get the wider angle, we really need to go to the KW camera, which is the image we started off with today. So likewise, I'll play here the whole eruption sequence from the very beginning. Night and day. In the daytime you can't see the glow as well, but here comes night, and you can see that full extent, the central area already uplifting there in the middle. And what you can see in a wider view is over here on the right, this southwest vent that popped up partway up the crater wall up there. And that's been feeding a little river that feeds this horseshoe-shaped lake as well, and has been building a little cinder and spatter cone around itself that we'll look at here shortly as well. So let me play that one more time. You guys can see the full sequence. Lots of gas there at the beginning. Depending on where they're posing the camera, you might get a brief whiteout. There you see that lava all the way around the back, a full ring at this point in time, and then breaking that eastern segment to the one isolated eastern pond, and then a horseshoe-shaped lake here. There you might have seen a little bit of that central area overflowing from the western basin into the lake right through there over top as well. And zoom into that area right there. There's our right in here is our basin. This is a spot where it reemerges, and here's that big river that's spilling over. You see that at the early onset, this western basin and this horseshoe lake were connected, was spilling over, and eventually that little rivulet dries up, hardens, and they seem to be two separate bodies now. Maybe connected within a crust and certainly beneath it, but just to document the evolution of these little features here within a larger eruption. I thought it'd be interesting to look at this just the nighttime views. So this is what this is. That same view, but I've cropped out the daytime, so it does jump a little bit because when eruption actually starts, you don't quite get that full crater floor covered in lava view. It's very brief, and there it was that first night. This is the second night, and here's the third night. Horseshoe Lake there, so a little bit easier to see that progression when it's all the same color more or less there, and I thought that would be interesting for you guys to see. So moving on, since there's so much to share today, I'll let you guys rewind if you need to. This is the S1 camera. We got from the south, looking at that eruption as well. From the onset, let's pull it back to the beginning. There it goes. Central island with the fountains around it. Those central fountains seem to largely die off. That first burst that came out of that southeast pit of the island complex in the center, that was the initial burst out through here. That seems to have hardened and stagnated almost entirely. And here on the right side, you see that eastern lake, and that's where it appears to be stagnating as well. So a lot of things I talked about there. Maybe zoom into some different areas. Let's look at the eastern side first. Reverse order. There's that eastern fusion source through that eastern basin, and a source right there. See that lava is now no longer connected all the way across. You just have the isolated pit, and it is still all red and overturning at the surface, moving pretty continuously until right around here you start seeing it pulse, move and stop, and move and stop. And that was earlier today, so that's the indication there that it might be stagnating on that side. And look how close it is to the rim right here. It's very, very close. This is where the area where it came down and sampled on that first eruption. USGS landing a helicopter in there and sampling, and we'll see a video of that a little bit later as well. So replay it. Central area. There is that initial burst around the island that dies all the way off completely. That lake actually seems to drain. The vents on the northwest side seem to fizzle out as well, and we do have a small pond in here, which seems like it's also stagnated as well. So interesting to note that that central uplifted area is largely devoid of activity now, apart from this vent right in here, which is coming up underneath the crust and then feeding into that western basin through that pathway that we saw this same thing happen earlier this year in January 2023 eruption. Okay, moving on from the S1 camera to the B1 camera. This is the one over in the on the east. And what I want to show you guys, this is the day before the eruption begins here. And just to show you what this camera looks like, you note the foreground here. We see the edge of the crater just in the bottom left corner, because the camera is right up against the edge. So what you'll see is that this is the day before, and then the day of the eruption. Right there, you can see already they've moved it back a little bit. Right there, there's a little bit more visible in the foreground here. It's not quite at the edge. And what ends up happening, I'll play it here, you'll see they'll move it back even further. That happened yesterday evening, afternoon and evening. There's a 6th, here comes the morning, here comes the burst of eruption. Across the crater, the camera moves back. The first full day of eruption, the camera still sits there, but so it gets this view of the eastern lake here in the foreground. Wasn't off, but then here it is. It essentially looks like it zooms out because now that lake is way over here. And in comparison, the camera is outside of that entire down drop block now and up on a upper rim again, once again. So it's a closer view to what you see from Kīlauea overlook now. And you can see that clearly we're concerned about that position for the camera. So now we're all the way backed up from there, here. So a lot of little details, and moving on here, we'll show you guys the V1 camera. Now this is one that they're running a live stream from, so they do move the camera around. That makes it a little trickier. So what I've done is I've edited this a little bit to slow down the spots where it's maybe moving, but it does move a little bit fast still. So here you go, an example of some of the in-between shots, different parts of the lava lake, the actual west vent, spattering points all through there. More lava bursts. I'll pause it right there. Here's these 2 different vents from that western edge. This is the one that appears to still be active, and the one here to the left is probably the one that had shut off in the last day or so. And the western basin just behind it right here. You see it spilling over into that horseshoe lake right there. Oh, there's some more of those still shots. The spillover right there is getting narrower and narrower. Eventually cut all the way off. Then we focus here on the southwest vent, which is building that cone and flowing back and in. And you see it seems like about twice a day they will come through and move the camera around and document all these little features as well. Different areas. So much activity in different places that are panning the camera around to capture a little bit of it every day. So just a quick take there on that. And what we'll do to keep moving here is just, let me give this a reload and make sure we have the nice evening view. There it is. From a KW camera showing that southwest vent still pouring in, feeding a horseshoe lake, which is also fed from below because there are other fountaining spots here and here and here, and fed from the outlets on the west side of this uplifted area. And of course still there's the central western basin lake as well. That's the KW camera. Let's just kind of scroll through it. Similar view on the F1 camera. As you can see there, you can see a little bit less brightness in the background. That back lake does appear to be stagnating still. And now to the, where are we at now? The V1 camera. And there is that southwest vent, slightly different angle. S1 camera from the south. So that southwest vent would be off to the bottom left of the image here. You don't quite see it. You do see that one upwelling source within that horseshoe lake here in the south, just off of that western basin, and a glow from the southeast pit that it has connected as well through the lava tube. And all by itself here, still showing a little bit of red on the surface, that eastern lake, quite a lot smaller than even last night, and this is going to change the viewing conditions from different areas as well. So this area of the crater is the one you can see from Wikahuna the most clearly, so Wikahuna seems to be not as good an area now, since that activity in the east has been waning. More on that soon. Here is the B1 camera. Much further away, looks like it's got some water or something on the lens there, so can't see it too well. And all the other cameras here are showing wider views that are interesting, but not really related to documenting the activity of lava there. So that's the web cameras. There's one more webcam, which is the National Park one, near Volcano House, and here's how it looks. And this camera is actually set up for air quality, and you can see now that there is quite a bit of fog in the air towards this camera, and this is what this camera is here to detect. But it appears to not be reaching the sensors just behind this camera at the visitor center, so interesting to note that. Maybe it's changing right now as it's getting dark. Okay, so moving on to some images. Here is a geologist observing a lava lake through a laser rangefinder, taking measurements. That southwest vent right here in the foreground, fountains in the back. This is early on. You can see lava covering that whole floor of the crater. June 7th also, so looking down from just above that southwest vent, here's what it looks like, building a little bit of a spatter rim. See the lava's shooting up and falling down all around that opening, and that's piling up and making this spatter and cinder rampart and cone a little bit, and feeding this rapids of lava down towards that main lake there. Can't see there's a second spot of spattering right in here. It's not as easy to see from just a still photograph, but we'll look at that some more later. And one more reverse angle. Now you can see there that upper vent, and it's actually a lower vent down here as well, with its own little spatter feature growing around it as well. So a little mini cone at the bottom and a larger cone at the top with a rapids connecting them, and it flows out through there, right? And not just those two spattering spots, it's got leaks as well. There's another leak right there where the lava is moving underneath this pile of cooled lava, hardened lava, maybe not cooled, and leaking out the bottom and moving off to that horseshoe lake once again there. Okay, so this is a video from Page Films, Lance Page, who was down with 2 pineapples, and I thought I would share this as he caught USGS scientists sampling the lava on that first day. He was there, watched the helicopter fly in. So show you guys this. There it is. It's on the ground. Geologist is carefully walking away from the helicopter. Down here at the bottom, at the edge of the lava lake, there he is, reaching over to collect a sample. Lots of gas all around there. And then taking off once again. The vertical format makes it a little bit trickier to make it nice for the screen for you guys. There they are flying out of the crater. Maybe I'll let it go through one more time here and try to zoom it in for you guys a bit. This is going to be at the... Oh, no, that didn't work. Okay. That's over. So one more thing. Let's go to the national park. And this is now a video by Janice Way with 2 Hawaiian nene, 2 Hawaiian geese dipping into the crater to take a look at the lava. So let me make this a little bit more screen size for you guys here. And let's push the play button. And watch, here they come, flying across at the top center of your screen. Right above that vent there, at least as the point of view appears. And off they go there. So life still continuing all around Kilauea. Nene still able to go about their everyday business, and people don't have any lava to worry about. It's mostly just the gas, and that's probably the more amazing thing, is that the gas doesn't seem to affect the nene that much, or they seem to get around it or have some way to deal with that. That's kind of an interesting thing to think about there. All right, moving on. More images. This is me. I'll play it first, and then we'll give a credit afterwards. So this is a video that was submitted to Hawaii Tracker. Looks like it's taken from the north, panning across that active lava lake. All the different spots of fountaining, bubble bursts, all the way to that southwest vent, which itself has been bursting quite a bit. So we'll focus now on the images of this southwest vent, since it's one of the newer things. It does remind a bit of that early December 2020 western vent as well, when it was above the lava lake level, building its cone and then feeding a river of rapids down into the lake that was filling up and eventually reached the level of that opening. So we'll see. It's got all the way to go. It's got this whole ramp to go still. So perhaps that won't happen here very quickly. Another video similar here of that western southwest vent area. And one thing that's been documented and reported even this morning is that there are occasionally very large bursts of gas from that vent, and sometimes lava will shoot in the air at what people believe is 100 feet, 150 feet. Hard to tell without a measuring stick out there, a ruler, right? But I'm sure at some point we'll hear from the USGS about how high this vent is above the base of that cone and above the lake itself. We'll have a better idea of the relationship there. But it's not unusual to think about the gas escaping, coming in different sized bubbles up through the pipe, and so you can get a bigger bubble of gas, then you can actually see it shooting the lava up farther. Now we'll turn to 2 pineapples, who also have been documenting this, but they have a much more stable setup with a tripod here. So let me pull this back and show you guys. This is from the first night still. No, actually it's from the second night. See those big bursts, see the lava falling down and building that spatter cone. That's how it grows. You can see why it's getting a more cone shape. It's not just flowing out that river, but it's really being burst into the air and falling back down and collecting into that shape, just like dropping a pile of sand on the ground. But it's rolling a bit, and then wherever it lands and hardens and possibly sticks, then it actually accretes and welds itself a little bit. There's that southwest vent there. Look at that second bursting zone here in the middle. Couple leak spots here at the bottom, and a big river coming down around the backside, wrapping around. It does seem like this pathway is evolving because it's fairly flat in here, so it'll build a little hill and it'll flow out to the right or flow out to the left or back over here and wrap back around. And so as you're watching these next few videos, you can look at all these different differences. You don't always see this middle vent bursting, you don't always see the oozes, but let's keep going. Different views at nighttime and daytime. So here's a daytime view, and this is an image of this vent collapsing from Two Pineapples. I happened to catch that in the early morning here. You see it's closed itself off, except the lava is still bursting underneath it, so eventually it destabilizes and falls back down. You see that pile of that brownish ash rising right there, different color from the actual gas, a bit whiter and blue there. And you can see now I'm going to kind of cut forward a bit, so you see there's that burst at the bottom. After it starts spreading at the top, it starts creating these little rivulets. The rivulets start coming down. They're just coming down the front. There's one coming down the right side as well. It's going to wrap around. Takes a little while, so let's cut again. And fast forward, cut again, so you guys can see the progression of it without taking too long here. Really amazing stuff. There's so much amazing imagery, like we said before, and really want to throw out a big mahalo to Two Pineapples. There's our local down here in the corner. They're on YouTube, and they've been streaming every day up there. Check them out. Really awesome, great views that they're providing for everybody here. So go check them out on YouTube, Two Pineapples. Mahalo, you guys. So that's that collapse in the daytime. Move to the next evening here, and let's pull it back. I'm not sure what happened here, but we'll just go from there. So a little bit wider angle view there. You see the fountains bursting mid-lake. Big burst out of the back here from the vent. You can see now in this case 1, 2, 3, almost like 4 different spots now where it's bursting out. Right. This is the following day. This is yesterday evening and this morning. And then more in the daytime. See more of those spatter vents. Right. So it seems like activity in this area is actually increasing at the southwest vent. Still vigorous fountains here in the foreground within that horseshoe lake itself. But you'd imagine as those eastern vents are waning, this southwest vent is picking up activity. We could be seeing a shift of activity towards the west here. And that wouldn't be surprising because all the lava that's coming out through the crusted crater floor is having to buoy and lift up some of that extra mass, which it can do for sure. We've been seeing that over the last 3 years, really, right? But if you have a vent that's open up to the side, then it's slightly less pressure to get out that way, and that might be a place that the eruption migrates to and focuses at in the long term. So we'll have to wait and see if that's actually the case, but fascinating to look at that and imagine that this may be the developing newer vent here. Moving on, one more. Oh, this is the one we actually just saw, so go in and show you one last one from the Two Pineapple crew here, and back to the beginning. And this is a little vortex of gas here that's caused by the heat escaping from these little holes, little puka on the crater floor where the lava's bursting up and bubbling. And here's one from the Two Pineapples stream in the foreground of that southwest vent there. And some more views of that thing. It's pretty amazing. And we'll move on from that one to show you guys a video that the USGS released as well of a very similar feature there. You can see how much higher it extends into the air. See if I can zoom this in without messing up for you guys. There's a crater floor, and all the way up you see that thing funneling. Pretty fascinating to see these features that we've seen before. It's just thermal effects visible with all that gas and fume that's being caught up in it, and basically lights it up so you can see it really well. All right, so there's another USGS video. This one was the overflight from yesterday. So we showed you guys the other overflight on our last update. But to bring you up to date, here is the one from yesterday, showing that wider view. Daytime, of course, so what's silvery is that active lava, that horseshoe crater here on the western side, this eastern pit right here, and all this other stuff in the middle is all hardened and showing a slightly darker color right now. That's the aerial view, panning around. This is Wikahuna up here on the right, old Jagger Museum there, Kīlauea overlook, and viewing area is down over here on the left side of the image, somewhere right in there. And yeah, panning around. This is all that down drop block area of the 2018 collapse right through here. And you can see really, even looking at the gas here, most of the gas is coming out this backside, maybe over here on this north side as well, but not so much in the east. So once again, suggesting that that activity might be migrating further to the west here within this pit. All right, mahalo to the USGS for providing all this fantastic imagery and the data we're going to get to here in a minute. And that's the full around. There is crater rim drive on one side and the other where it collapsed then. And we'll leave it at that and move on. Still looking at images. This is mostly what we have today. But to share from Hawaii Tracker, just wanted to share that we have a new contribution from Eric Kabik right here. New eruption images June 7th and 8th. Ground images on day 1 on June 7th in the evening, and aerial images 10 a.m. on June 8th at 9,000 feet due to FAA regulations. So he's got a whole bunch of these on Hawaii Tracker, but what I'll do is just pick out a couple to show you guys. There's one from above showing that southwest vent and a little river that feeds into the horseshoe-shaped lake here against the western edge. So pretty nice view. You can see a piece of the old road right here, and then where it connects up here in the top left as well. Maybe you can't see that so well. Zoom it in for you, but there is the piece of road. And then further north, you can kind of see below that, the left, there is that southwest vent. Okay, look at the next one. So from the ground, it's not quite clear where this is. It could be Waldron's, it could be somewhere by Volcano House, it could be or Kīlauea as well. I'm not quite sure, but I really like how he's captured this. He must have been back a little bit and zoomed in. It looks like people are right there within the crater, which they're not. They're way further away, closer to the camera than they are to the actual image here in the background. But really fantastic storytelling here. People looking at the eruption, making it look like they're right in there. Okay, so that's the couple from Eric, and mahalo Eric. And a couple we'll throw in today from Andrew Hara, courtesy of Paradise Helicopters. Andrew Richard Hara. An image that we didn't show you guys yesterday. This is the one up at Wikahuna. So here's a former Jagger Museum parking lot, Kilauea Overlook parking lot down over here, in a spot that's been a good viewing area here in between, right in there. And this is the spot that looks to this part of the crater pretty much, and where activity is diminished, and thus maybe not the best location anymore. Another one from Andrew to highlight for you guys, another aerial view from the first day, showing the lava covering most of the crater floor at this point in time still, and all different vents all through there. Okay, we've been talking about viewing for a while, so maybe we'll officially turn to our lava viewing segment here. And first I'll highlight the tweet from Hawaiian Volcano National Park. You like spending time stuck in traffic? Then visit the park between 6 and 9 p.m. during eruption. Seriously, traffic and crowds will impact your experience every night of this eruption. Better experience try just before sunrise. There you see long lines of cars. If you're lucky to get there early enough and just open spaces, you can just pull right in, no problem. But once the parking lots are full, then they set up the roadblocks, and the rangers then only allow cars into the parking lot once people leave. And as you imagine, people don't leave in a steady stream. It takes a while for them to trickle out, depending on how long they're staying to look. So people can be waiting in their cars for a while. So good advice to come either later at night, early in the morning, even in the daytime early, and then be willing to wait, not in a car, but somewhere in a rim for a while for it to show up. That kind of thing might be the best approach. So looking at the actual map from the national park, the main visitor center over here, Volcano House at 1, Uwikahuna at 2 over here, Kilauea Overlook, and Kīlauea around the south. So let me zoom it in a bit here. What we'll do is we'll show you guys some characteristic views across the last few days here from Uwikahuna area, from not exactly Kilauea Overlook, but close. The section in between Kilauea Overlook and Wahine Kapo, a steeping bluff. I'm show you the images from here as well, from Wahine Kapo, from Volcano House, around at Waldron's Ledge, Kupina Ipali right over here, and finally Devastation Trail to Kinakakoi Overlook in the area over here. So we'll start at the top and work our way around clockwise. And here is a view from Uwikahuna. So you can see, zoom in a little more. This is why you really see that eastern edge of the lava lake. This is that central area where that eastern pond is still hanging on barely, but it's just that size nowadays, and all the other lava that was visible on this first day all the way to here and here is now hardened. And if I scroll it further east, you can see that the view is obstructed by this other block from that forms part of the Caldera Rim right here. So you can't see the southwest vent directly, and you can't see that horseshoe lake much at all, except maybe this one arm of it over here. So thus Uwikahuna, while it was excellent here in the first few days, may not be as good a sight, and that depends, of course, what you're looking to see. There is still lava visible from there, which is obviously better than none, especially if it's too crowded somewhere else. But you see what you can and can't see from here at this point. So moving on, this is now back to the area between Kilauea Overlook and Wahine Kapo, near KMC area. And there you can see the western vent and a little bit of a sliver of that southern arm of the Horseshoe Lake, but you don't see much off of that eastern pit, or the eastern part of the lake at all, right? And nothing of the northern either. Just a little sliver of it visible from there. As you work your way around, here's Wahine Kapo, the steaming bluff. You don't see a whole lot from there. If I zoom it in for you guys, you once again see a tiny little sliver, but you can't even see the southwest vent from there, actually. So there's a little bit of a blind spot, so to speak, there on that part of the crater here. So pull up the map again. So right in here is a little bit of that blind spot, and now that you can't see as much from here, it's kind of this whole northern side is not as good to look at. It's more the eastern and the south where I would recommend people to go moving forward here. So that was the steam vent. So okay, Volcano House on the east side. This is a view we showed you guys yesterday. Lava lake clearly visible from there. That southwest vent as well. There it is. And we do have that National Park webcam, and so I'll play you guys. There it is, zoomed in and cropped, what the whole eruptions look like from Volcano House, where this camera is actually placed. You see pretty good. There's a lava lake bubbling in the middle, southwest vent in the back. Night and day, not as bright and glowy in the daytime. Obviously, you do see the few spots of red, but you can see that full shape of the lake much easier in the nighttime as the lava energy emits through that very thin crust that it's forming against the air. So that's Volcano House. This is Waldron's Ledge. Just clipped this from Two Pineapples once again. It's a little bit blurry because it was an inset image, but there's Mauna Loa panning from north to south. View of the lava lake itself, western vent in the background, southwest vent in the background. And you can see both arms of that horseshoe lake from there. So good view in the east there from Waldron's Ledge. And moving around to the south, this is Tornado Tim from Kinakakoi. This is on the first day. Zoom it in for you guys. And you can see a little bit different view there. You don't see the southwest vent as easily from right there, but you do see full circulation there. Yeah, just one view, and of course there's different areas to look at in the Kinakakoi region. So show you guys one more view of it, and here it is. This is from our friend Galen Alpine from Hiccup Circus, who we've been spending time with at the KMC here recently, and shared this with me this morning, showing once again another view of that horseshoe-shaped lake and that eastern pit in the foreground right there. Zoom in a bit for you guys. Eastern pit, horseshoe-shaped lake. There is that western basin lake right in there, and as you can see, not quite visible that around a corner, that southwest vent from there. And so really the areas around Volcano House and Waldron's Ledge give you the most encompassing view at this point in time. What that means, it's been very busy there, super crowded. Can get windy there. It can get a little drizzly there sometimes as well. So that's what we're dealing with here with lava viewing. And that concludes the lava viewing report. And we'll switch now to our monitoring signals, which are not as extensive and as important as usual, but cover them anyway, starting with the most important part of it, which is the USGS text updates, starting with the one from yesterday, Thursday, June 8th. We were just switching over to watch in orange. We'll see that here in a second, but the volcano is erupting, activity confined to Hale'ema'u, and no activity along the rift zones. That's the most important stuff there. In detail, multiple fountains remain active in the central portion of the crater floor, and one vent is open above the crater floor on the west wall of the caldera. Lava fountains have decreased since eruption onset, but remain about 10 meters, 33 feet high. So that's the value. People are always asking, how tall are the fountains? The answer is about 10 meters, about 30 feet high. The area covered at the crater floor was in total about 370 acres, 1.5 square kilometers. And after an initial rise of 6 meters or 20 feet of depth of new lava added to the crater floor, measured by the rangefinder, the lava level has decreased over the past day by 2 meters, 6 feet, likely due to gas loss. This is where I'm getting some information to share with you guys. This drop left a bathtub ring of cooled lava along the cliffs at the edge of the crater floor, and an average diffusion rate of approximately 150 cubic meters per second is estimated for the first 24 hours, based on the rise in lava lake level and assuming a flat surface. However, the estimate's likely inflated, doesn't account for vesiculated, that means lava with bubbles, and variations in topography across the surface of the crater floor. However, the very earliest phases of this eruption appear to have an effusion rate that was significantly higher than the previous 3 eruptions, based on rapid coverage of the entire crater floor. Right, so that's a potential there. We did see in excess of 100 cubic meters per second for both the previous eruptions, but maybe not quite as high as 150 in that range. The other possibility to consider here is that they didn't mention this loss of gas all through here, right? So measuring lava with extra gas is harder to get the actual volume of cubic meters per second with the gas scaled back to what's considered normal, or to, what the geologists like to do is the dense rock equivalent. Like if you take out all the gas, how much is actually coming out of the lava itself of the rock. So some nuances there, but still high value, and that was corresponding to that initial value of 65,000 tons per day that was measured on June 7th. And as has been shown before through research in Kilauea, the gas emission rate is very directly proportional to the amount of lava coming out. So 65,000 was the amount of lava coming out, was related to that maximum lava coming out at the beginning. And if we were to go to today is at 21,000, and that means that the rate might have possibly dropped in about half or so, right? And showing how much more gas was in that first phase of the outburst. Okay, so that was the yesterday morning update, but they did also report or issue a new volcanic activity notice, VAN. Here, this was at 8:37 a.m. And this is what was changing the activity from red to orange and from warning to watch. And it just basically says that the initial high effusion rate has declined and no infrastructure is threatened. So that is basically it there. And why they downgraded the volcano once it was clear that the initial phase had passed and the eruption had actually stabilized. And that's the important thing. It's stabilized. There's no sign of anything going anywhere else. It's still just a caldera. No earthquakes anywhere else, as we'll see. So it's really just as expected, bursting out the middle there. So the update from this morning, they do note multiple minor fountains remain active in the western floor, and a southwest wall continues to feed lava onto the westernmost part of the crater floor. Height's the same. Active lava and vents cover much of the west half of Hale'ema'u crater in a broad horseshoe around a central uplifted area. An active lava lake is centered within the uplifted area and is fed by a vent in its northeast corner. This feature is the western lava lake from prior eruptions that's been reactivated, along with a smaller circular pool just southeast of the lake. A much smaller area of lava also remained active in the eastern portion of the crater floor over the night. And over the past 24 hours, the level of the central lava lake has increased by approximately 1.5 meters as measured by rangefinder. So it seems like it dropped and then it came back up since then, and we'll show you that on the monitoring data here in just a few seconds. Otherwise, tilt's been deflationary. There's a volcanic gas measurement of 21,000 per day on June 8th. Otherwise, no unusual activity in either rift zones, and nothing else is different from the report here. But since this is a new eruption, it's worth noting that there is additional hazards like Pele's hairs, like lightweight glass fragments from the fountains, and the winds blowing the small particles and the gas great distances as well. I don't know if I read this during our initial first quick update as eruption began, but let me pull this up here just to, forgot I wanted to say this earlier, but go back to the update from, let's see, which was it? I think it might be this one. They actually noted that residents of Pahala, 20 miles, 30 kilometers downwind of the summit, reported a very light dusting of gritty fine ash in Pele's hair that morning, the first morning of the eruption. So that's the other hazard to mention there. So all right, let's move to the graphs. This is the graph of lava depth. So there is pre-eruption, lava is just kind of small scale variations there. The initial outburst jumps from 388.5 up to 394.5. And then here is where it's going down, right through there, right? That's the likely gas loss right through here. And then you see it stepping back up again. And this is likely that refilling of that western basin, which is what this plot is measuring. It's just measuring the lava level within that west basin only. The tilt, you can see very similar signal, but the tilt is not going back up since the actual break of the ground and then the release of lava. It's been deflating fast at first, slowed down a little bit, accelerated again, but it's overall on its long-term decline now, as expected. And at some point, we'll see it actually switch back to inflation, and then we'll know that that initial outburst phase is actually over. So we're still in that, maybe it's flattening here, and so maybe that first outburst phase is ending or just ended here, and we might see it turn around at some point. Or we'll see. We'll see if it keeps going down or not, and hard to predict what's going to happen there exactly. Zooming out to the last month, here it is. That was the last week, just right over here. And a couple of little earthquakes that made our horseshoe-shaped or our tooth-shaped signal on the plot back here on the 20th, 21st. And I thought I'd show you guys the ambient gas measurement here. So this is at Sand Hill, so it relies on a wind to blow the gas in that direction. Maybe before we'll be looking at little variations here between 0 and 1 ppm, but this is really showing what the eruption actually looks like. We jumped from almost 0 to over 4 ppm of SO2 in that one location. It's not steady in one spot because the wind is changing it, and it's going to blow it across the sensor for it to actually pick that up. So that's why we often prefer this integrated measurement of SO2 that USGS does by measuring everything and doing a lot of math. And here is that high peak value of, in this case, it's plotted at looks like 75 or 77,000 tons per day rather than 65. And then the most recent two, 21,000 and 20,000 tons per day down here. This is the last month, right? Prior to that, we were all in the hundreds back through here. So looking at the last year is a little bit more instructive. Here's our high point once again, 70, almost 80,000 tons, the 20s right in here. Even right now at the 20s, we're higher than the first outburst that we saw back in January, where we actually hit somewhere in a range of 12,000 tons per day. Some of the other eruptions might have been a little bit higher than that, but they're off the graph here, so it's harder to compare them as directly. Okay, the GPS now at the summit. The summit's been expanding. Here's the whole last year, so it was filling and spreading, all the way through here. This was a January eruption right through here, so it actually goes down. Eruption ends, it resumes, it's swelling and spreading. And at the very, very right end here, hard to tell exactly what's going on, but the crater seems to have popped open more. So it may well be that that happened during that initial outburst of eruption. And interesting to note that it seems to be still spreading in a second day. So still that first burst coming through and out. And what you would expect is that at some point this will turn back around and it'll start dropping back down again, like we saw over here, right? You see once again in this area, not quite as dramatic, but one point a little bit higher where it maybe burst up and then it waned back down again. So still, there's sometimes a little bit of a lag on this data coming in on the GPS and 1 point per day plotted. So we'll wait and see by early next week what changes are present on this graph. But importantly, on the same time scale here in a rift zone at Pu'o'o, we're not seeing anything like that. It's just a steady down contraction across the rift zone at Pu'u'o, tilt at Pu'u'o showing the same thing. So really no effect on the rift zones at all. And even that upper east rift zone connector area, which is more this green line, is now also deflating after last week. I'm sorry, this is the wrong station. So yeah, both signals here deflating. And yeah, present up the rift zone as well. There's not a whole lot of tilt meters to rely on, and this is one of the good ones to look at for the east rift zone at Pu'u'o. So the last month in earthquakes, here they are, earthquakes per day. The highest value was 200 almost a month ago, 3 weeks ago or so. You see we've hit other peaks, but here we are at the very right end of it, way down. Yesterday was very low. We're down range of, looks like maybe 20 earthquakes per day, and then today it might even be lower than that. So earthquake counts have crashed. That's expected because there's no need to pressurize and push the ground apart anymore. Here's earthquakes per week for the last year. And similarly, we're still in the first week of eruption, so we're going to have those counted in this bar as well. You'd expect that this one is going to stay about this height, and then the next one will be even lower than this, maybe back to these levels we saw. Well, it's probably off this map here, but back here prior to July, or in some of these low periods during eruption right through here. So here, January to March, a good period to prepare when lava's coming out of the ground and less earthquakes. So that would be normal. And keeping in mind that this plot counts not just the Kilauea summit, but also the south flank and the Pahala region as well. So moving to our earthquakes, this will be our second to last thing here. Earthquakes, recent earthquakes on Kilauea. These are the earthquakes for the last 24 hours. There is just one showing up here, 2.5, 15 miles down. So that's that feeder source coming into Kilauea. And you have the southwest ones as well down here. And these ones also 22 miles deep, 21 miles deep, maybe 17, 18, and 17 and a half there. So all deep earthquakes, not a whole lot of shallow going on there. This is just the last 24 hours. So if I pull it back to the last 7 days, you see a little bit more. There is the yellows of the actual sequence that began the eruption. You do see on the sides a little bit of activity too. But what I thought I'd share with you guys is a screenshot I took of this same map the day the eruption began. So at that point in time, the orange markers are the actual lava outburst. And looking at the summit first, this is a zone where lava burst out, but you actually can see it's kind of squeezing in here, and it's pushing both directions, both in the northwest and southeast. And you have two zones of extra quaking. It's Nanakani Payo to the northwest, and that zone, Kilauea, looks like it was that eastern part of a symmetry that's actually showing right here. And it's interesting to see it actually pressurize on the east side as well a little bit, not as much as the west as we saw, especially towards the end, building up to the eruption, but also seems to fit that pattern. And you see this kind of tail leading off to the southwest. In the past, we've talked about how these ones got deeper and deeper and deeper the more southwest you actually went. And I thought it was interesting to note that as eruption was, in that very first day of eruption, there were quite a few earthquakes in this area, this deep zone of Pahala, right through here. These two red ones are showing the most recent ones. And it's hard to know exactly what's going on there, but it does hint at some pathway, right, from here to here, without earthquakes in the middle. But as we saw effects here, the effect seems to propagate and eventually reaches the very closest spot of the very closest cluster to Kilauea. And here's maybe I'll go back to the actual map here, and I can pull it on to 30 days. This is how I got it, 30 days on magnitudes. Gives you a similar thing, but now it's not quite as highlighted. But as far as the Pahala cluster right through here, you can see that's actually well defined in 3 clusters. This is the one closest to Kilauea, closest to Mauna Loa, and closest to Lo'ihi, Kamaehua Kanaloa. So it seems like these could be different branches of that hotspot feeder zone towards each volcano. And if that's the case, then it would make sense that the very closest part to Kilauea might be activating, and you relieve pressure up here. So then once that happens, you can either have magma coming in to fill that extra space, or repressurizing, depressurizing as it propagates. Magma from below trying to replenish. Not quite clear exactly, but there's various reasons why you might have earthquakes along that feeder zone in response. And so I thought it was pretty cool just to note that there might be that little hint right there that was revealed in the immediate moments and hours after the eruption began here. And yeah, that's what we're still seeing ongoing with earthquakes down there right now. The one day and this one, these fit into that area, not quite that Kilauea cluster, but same zone and similar kind of thing. And actually, since then, the Pahala cluster is not that active anymore, right? It's still active, but not as much as before, so maybe it is relieving that pressure from the hotspot feeder there. Okay, so that is our earthquakes, and there's only one last thing to cover today, and that is this week's Volcano Watch from the USGS. So Volcano Watch, here it is. Reflections of recent eruptions. This is another in a series of recent eruptions that the HVO has been able to successfully forecast. Right, successfully forecast is their tag here. Opening image of the eruption here when it's still coming to flood and wrap around. There's no horseshoe in the west. It's almost a horseshoe in the center part right now, right? But it's going to evolve since then. So for days to months of all eruptions at Kilauea since 2018, as well as Mauna Loa in 2022, increased earthquake activity and ground inflation suggested that magma storage systems below were under stress. HVO scientists have noted these periods of increased unrest and closely monitor data streams for signals an eruption may be imminent. But in most recent cases, the signs of an imminent eruption became evident only about an hour before the eruption occurs. The clearest signals for these eruptions are rapidly occurring earthquakes, most not large enough to be felt, as the rocks beneath the surface break, along with an increasing rate of inflationary ground motion as the pressure builds. So these signals indicate magma is creating a pathway towards the surface. Eventually, the fountains of lava burst from the ground and a conduit is established. And then volcanic tremor, a signal indicating fluid movement like the hum of water moving through a garden hose, begins to replace the earthquakes, slowly becoming the dominant signals. An outlier is the onset of the January 2023 eruption on the summit of Kilauea. This eruption occurred mere weeks after the previous one had ended in December 2022. And maybe because of that, there was a slightly different sequence. Rapid earthquake activity occurred for about 30 minutes, followed by an hour of relative seismic silence before lava broke the surface with eruptive tremor. One hypothesis for why this occurred is a large amount of molten material stored beneath the surface of the crater floor, in combination with a short time frame following a previous eruption. So they actually have released some spectrographs here. So there is the actual line marking eruption actually begins. Earthquake activity is shown by these spikes of red on the left side. These are all different stations on Kilauea here. And the band at the bottom, that's the actual tremor, the lava moving through the pipeline, or like water through the garden hose vibration, right? Or I like to say when you blow air through a flute, similar kind of thing, increase the vibration. In that case, you can hear the sound. This instrument is actually able to hear that frequency under 5 hertz here of eruptive tremor coming out across the volcano. So there it is. With close attention to the data on June 7th, HVO scientists were able to identify the precursor activity that closely mirrored recent eruptions. They elevated the alert and aviation code to watch orange at 3:14 a.m., indicating eruption was imminent. Staff were notified and hurried to the rim, and just before 4:45 a.m., the fountains illuminated webcams and eruption began. So that is the story of today's Volcano Watch. And with that, since it's been a long week and it's our third update here in 3 days, we will call that good and say some mahalos. Dane, if you'd like to take it from here.
Yeah, sure. Appreciate everybody for tuning in today. You know, we rely on viewers like you to help keep the algorithm appeased and happy. Every click, like, subscribe helps us with the YouTubes and the Facebooks. So appreciate all that. We also like to thank County of Hawaii and the Vai Grant program for helping make this content possible for the past year. The videos, the live streams, and the written updates. We also had an A50 super chat come through from Susan L. Appreciate that one there. Yeah, everybody that just, hit the like, subscribe thing. It does help. We do have a few questions here if you want to take those.
We'll give it a shot.
All right. Victoria asked if this eruption is bigger than the last 3.
Well, so they're saying that the actual initial effusion rate is larger, but it's hard to tell if it's bigger. My measurement of how big it is how much lava comes out over the course of the full eruption. So the first burst is just the first part of it. A lot comes out during that phase. We don't have any official measurements yet from USGS. Even our estimates are a little bit generalized because they're not accounting for the shape of the crater floor beforehand. So what we really need is for them to actually have gone through with after their helicopter flights and do the full DEM from their photo from motion structure from motion software that they can take all their photographs from different angles and then actually make a 3D model and then model the ground surface and make a DM, and then they can do it again and then subtract the two elevations and then you can get a real accurate volume there. That's not instant, obviously, so it takes a little while, and that'll be what really determines, to me, eventually whether it's a big eruption or not. But certainly, more gas at the beginning. Reports of flooding of a larger area of the crater floor. Remember, the crater floor is bigger than it's ever been, wider and broader than it's ever been, and the whole thing got flooded and possibly even lapped on to the edge a little bit. So that's a big outburst at the beginning. But as I said, that initial drop that followed that may indicate that might have been a very, very gas-rich initial outburst. So it's hard to compare like a really frothy lava with frothy lava with a lot of gas. Lava slightly less frothy. Compare the volume, it's not going to be the same thing. It could be some amount of lava, just extra gas, and so that's really hard to tell which one is bigger at that point in time, right? And so that high volume, I guess, at the beginning, is that purely all fresh lava coming up? Or is there some buildup beneath the crust of some other stored gas, and that's why that first burst is so gassy, and then why it drops off so quickly as well at the beginning. Show you that plot once again, just because that's what I'm talking about here. This right here at the top, right here, right? So it drops off, and then refills back up there. So that's the best we can say here, right? And going on what the USGS are saying, fusion rate a little bit higher, maybe gas output a little bit higher at the beginning, but we'll have to wait and see how long it actually lasts. So possibly, yes, maybe Victoria might be the best answer. So we can kind of discuss it as time goes on as well, but that's all we can say at this point early on without any numbers as far as volume or official rates or anything like that.
All right. Next question would be: do we know the height of the like? I know we were talking about it, and do we know the height of the initial fountains?
We don't exactly, right? So, this is from Bob. I saw Bob was asking in Telegram, and mahalo Bob for all your effort with capturing cameras as well. But the answer is we don't really know. So what the US just has said is that the first bursts of lava were as high as 60 meters, 200 feet. That doesn't seem to quite jive with what we see in a video, right? So if we look at the video, where's the video of this? Let's see if I can just drop it on here. There, so there's a version of it. The initial burst of lava from that central crater floor. And there's a way to measure height just by the actual time it takes a particle to fall from its highest point to the ground, right? So when you measure, we talked about this a little bit, there's that first burst of lava outwards, the lava is up to maybe around here, and this is a real-time video from the live webcam. There is that highest burst, that kind of second one, so there's a particle right up there. You start counting. I don't have a stopwatch on me, but by the time that lava gets all the way to the ground, it takes probably at least 5 seconds, maybe 7 seconds. And if that's the case, then you're looking at somewhere in a range of 600, 700, 800 feet high. That's not the 200 reported so far. We do know that it takes the USGS some time to have time to go back and review this video and do that calculation. So I'm still hoping we hear an official number from them coming forward, but unofficially I've seen 700 to 800 feet potentially, maybe 600 if you're going to be a little bit more generous with your counting and errors there. But this one right here, where we are now, that might have been a 200-foot burst right there, it looks like, right? But that very, very first one looked like it might have been higher there. So there's no good answer there, but that's the discussion that can be had around that question. So mahalo for that.
I wonder what the margin of error is on that when you have gas-rich lava, essentially. Think there's any difference?
Well, so the gas is what's pushing it up. I suppose the lava fragments themselves, maybe more of a matter of how much air resistance it is when stuff's falling back to the air. Right? Is it floppy in some way where it can kind of be like flopping around and slowing itself down?
Right, and then it would give you a higher make you think it's taller than it really is at that point.
Yeah, maybe, but even if it's falling from that high up, then it's not going to vary by that much percent of the entire measurement, right? So yeah, that's an interesting question and discussion with no official answer yet. Yeah, but some contradicting information there, right? So yeah, good question. One that we're still wondering the answer to ourselves officially. But given the video we just saw, I'd tend to believe more the 600 foot or higher than a 200 foot there.
Right. Final question. So, Christian asks, how does the volume now compare to prior to 2018 inside Haleʻiamamao? This ballpark.
I haven't done the calculation exactly because we don't know the volume that's been put out in the last 3 days. But what I can say is that through the end of the March 2023 activity, we were more or less 20%-ish. 20% of the volume that had been lost, we had recovered. So I would imagine we're in that same ballpark. Call it between 20 and 25 or 23%, somewhere in there, 22%. That would be my guess, something like that. Okay? So it is interesting to note that that's like 1/5 of the volume refilled. But as far as depth, we've refilled a lot more, maybe 75% of the actual depth. It's because the whole thing comes up from very skinny, and then flares out, and then flares out even more at the very top. So we've now we've filled in that very lowest funnel, filled in most of that next funnel, and we're almost to this flare out spot at the top. So it's going to be hard for it to gain any more elevation because it's spreading out so much across that area, right? This one lake, as it refilled that first burst, almost 400 acres, right? That's a huge area there to be refilling. And that's just one small part. That doesn't even count that larger down drop block area, which is much, much wider. So it's going to take a while for it to actually refill that entire hole. What we can hope for is that now that we have that southwest vent above the lava lake level, that it sustains for a while, feeds down into that lake, and eventually that lake overflows onto that lower down drop block. That has a chance of happening. And that's the most exciting thing looking forward. But it's going to take a long time to refill the entire thing. So what we'll see is probably years of lava over that down drop block flowing down and over and down and over and down and over before we get to the point where it might actually even reach the far crater wall and start filling that in. So it's going to take a long time. And something will change before that process is done, right? I won't keep refilling without eruption stopping again, starting again, something else changing. So yeah, 20%-ish is the best estimate I would have, and knowing it's not accurate, not taking into account what came out in the last few days here.
All right. Well, I think that does it for me. We will be expecting 2 pineapples to be going live this evening, or not this evening. Let's say what it is, early morning. When there's no people up there and they can find a good location. Hopefully it's not too windy, cold, rainy, and all that stuff, so we can get some good live long stream action from unique angles, different from the USGS cam. Be able to see a little bit more that way. So, yep, until I believe we were planning to come back on Monday.
Yep.
With another update, probably around 5 p.m.-ish. Keep going on this thing, cover whatever happens over the weekend, give you a recap, and cover anything new.
Yeah, and so yeah, we'll try to catch back up on Monday, and then moving forward, we'll have some schedule changes from that, but we'll talk about those on Monday, and just have a good weekend from now until then, until Kamehameha Day.
Right. All right.
Well, thank you, Dane. Thank you all you guys in the chat, and all you guys who contributed, donated, and all that. We appreciate that. We do take donations on HawaiiTracker.com still. But until Monday, from Hawaii Tracker, Dane DuPont, I'm Philip Ong. Aloha, everybody.